se. Jo, tak... No. Já nepotřebuju brýle. aspoň nebudu vidět, kdo se na mě dívá. A jo, ještě vyhodím žvíkačku, dej mi sekundu.
Halo, halo. Halo, halo. Není slyšet? Já jsem to odmutnul. Jestli to teda nemutli zase znova. Slyšíš mute? Není tam mute. Není, ne, když to není to. Halo, halo. Tady to je slyšet, ale tady to není vidět. Halo, halo. Halo, halo. Halo, halo. Halo, halo. Halo? No tady to jako dělá klipuje, že? Ale tam už je to slyšet? Tam prostě nejde bez toho. Halo, ale to dělalo? Kde je gain?
Dobrý. Takové růžové, jo?
Halo?
Pecka.
Halo? 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 Počkej, já jsem to tady slumil. Haha. Halo? Halo, halo? Mikrofon funguje?
Jasný, tak mám něco říkat, něco říkám. Nic jsem neklikal.
Pardon,
Test. Něco říkám. Něco říkám, nic neslyším.
Něco říká? Říká něco?
Halo, test.
Teď já tady slyším. Ještě.
Něco, halo, test, 1, 2, 3.
Tak já stojím na tu hudbu.
Halo. 1.
Jo, už to vidím. Tady tam to je.
Pozor, 1, 2, 3.
Jo, to je asi dobrý, ne?
Slyší mě lidé? Slyší mě někdo? Zvedněte ruce. Dobrý, někdo zvednul ruku, takže asi mě slyší.
Tak to dáme takhle na nulu.
A teď?
Ještě.
Mic test, hello, can you hear me? 1, 2, 3, 1, 2, 3. Yes.
Na nulu a tady to je taky, jo? Ještě něco?
Perfect, yes. Good.
Tak jsme to připravili.
Čau, Marku. Nesmím nic říkat, protože myslíš.
Hello. Mic test. Hello. Hi, can you hear me? Is better now? Hello, can you hear me? Too quiet. But now, hello. Is it working?
It's too
Quiet.
Way too
Quiet.
Still too quiet.
Prosím?
Ten výstup si zkoušel?
Ne, neskoušel.
Zase.
Co tam je?
Halo, halo, prase kozu potrkalo. To už je, a to je dobrý. On totiž mluví hrozně. Kde je vysílač? Tak já tam jdu zkusit to povídat. Halo, 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 prase kozu potrkalo. Halo, halo. Teď je to dobrý, ne? Musíš to držet.
Stay. 3, 4, 5.
No, to víme, no. Ale co je dělá? Halo? A mě slyší dobře, ne? To je jenom Viktorovo mikrofon. Tady bych chtěl, aby nebyl žádný mobil. Jakoby odsud, teď takhle, tady tenhle ten kabel, tenhle kabel. Ale ty tam máš jiný, to nemůže být tím, protože ty máš jiný kabel, to máš kratší. Halo, halo. Halo, halo. Ještě no? A tady je někde jídlo?
Hello. We're gonna begin in a few minutes. better.
Neslyším. Já to asi... Ho. Halo. Halo.
Hello.
Dobrý. Ale ten tak...
Device is 2.4 gigahertz because it thinks that it interferes with our microphones. Because it was okay before you came here. There's no bring trash and this.
Halo.
Nemám vyndat svůj mikrofon? No to jo, nebude mít záznam.
Vy... Jo, dobře.
Tak to ukřičíme.
Hello, hello. No, here. Sorry about
Halo? Halo? Že tam seš... Tam nikdo nešteluje mikrofony.
that. Hello.
Musíte
Hi.
tady. No tady na tom se to musí štelovat. Halo?
Hello. Hi. Can you hear me?
Technology failures?
No, I can't be heard. Am I? Can
Okay.
you hear me?
Yeah, it seems so.
Really? Through the microphone?
Yeah.
It's kinda quiet.
Sorry for the delays, for the issues with the microphones.
Yeah, but anyway, welcome here to Backendisti.cz event. I'm here, Victor from Backendisti.cz, together with Petr from FNX.
Hello.
And we've been organizing these events for quite some time. And when we started, we decided that we were going to organize it every other month. But in 2019, we got a quite significant delay for almost a year. So here we are back in new year. So hopefully this year will be better, and we'll have interesting topics for you. Which brings me to today's program. We have three talks together. The first one will be from Jakub from Pipedrive about simplifying complex code. Then I'll have my talk about IoT, and then we have a talk from Muse about zero downtime migrations. So I'm really looking forward to it. And yeah, but
Let's
Peter,
begin.
if you would like to add something.
I have no things to
Okay.
add. Okay,
So-
let's start.
Let me introduce our first speaker, which is Jakub from Pipedrive. And Jakub, it's yours. And sorry again for the delay and for the technical difficulties.
Perfect. Yeah. this was, I hope, the most difficult thing I will do today. Okay, so thank you for coming. My name is Jakub, and yeah, this will be about domain-driven design, which is probably my favorite topic. I changed the title a bit about from simplifying complex code to writing simple code, because I don't think the code needs to be complex in the first place. And I will just start the timer here. All right, so I want to start by showing you this, this big ugly ball of mud, nasty, dirty. You basically don't want to have anything to do with it. So why am I showing it to you? Because sometimes it's the code which looks like it. This architecture pattern is called big ball of mud. It's an actual thing, and it's sadly very common occurrence in the software we see around the world. Like it's you can imagine what's wrong with it. Like it's dependencies everywhere, like cyclic dependencies, like global state, like things touching things which they shouldn't be touching, and so on. It's kind of very common occurrence, and even good programmers produce it. It's typically caused by some lack of system or lack of thinking, and just for kind of fun, there is an actual scientific paper written about it, and I love how they put it. Like it's almost poetic. Like the big ball of mud is haphazardly structured, sprawling, sloppy duct tape and bailing wire spaghetti code jungle, and things like that. So I really like it, and this talk will be about like how to avoid it, how to not let this become your software. And the question for you at the beginning, like, do you think that by choosing a better technology we can avoid this those big ball of muds? Like who thinks it's all what it takes is to choose a better technology? Can you raise your hand? One person, thank you very much, at least something. Yeah, I wouldn't be asking that if I thought that's true. Actually, I think like we as developers too often talk about technologies and tools and frameworks and how a new library is cool, you know, and it makes us sound smart in meetings, and other colleagues which don't understand us like feel that they are less capable or something. But in reality, I don't think that technology is the most important ingredient to good code or to like simple and maintainable code. We usually put like softer skills in software tool roles like business analyst and such. We consider them less cool for some reason, but I think actually those softer skills are a key component to building a good systems. And my goal with this talk is to convince you that this is true. Before I get into details, a bit about myself. So yeah, currently I'm at Pipedrive in the new Prague office, which has been established around a year ago. Those are the technologies we use. If you are interested in changing your job, we are hiring, of course. I needed to write it on the slide, otherwise I would forget. So check us out. I'm very happy there. Before I was doing an engineering manager in Skyscanner in London. About most what I know there, and that's simply because Skyscanner was or is one of the 100 most visited websites in some countries. As you can imagine, the scale is enormous, and that the huge scale brings like really interesting challenges and really difficult problems to solve. So I recommend you like joining company which has very high traffic. I think that's super. Can hear me? Is the mic? Or so give me a second.
Is this one working? 1, 2, 3, 4.
All right, this should be better, but you cannot hear anything, right? Or can you hear? And is it okay? I cannot hear myself, so sorry, I need to ask you. Is it better? This one? Okay, thanks. Okay, so back to the talk. So before Skyscanner or before London, I was in Brno. I was doing .NET, like really deeply just .NET. You know how it is. Nothing interesting happened there, but I wanted to put it here because I have a friend in the room who's a Brno patriot, and I think seeing this logo will make him happy. So that's why it's here. All right. So again, quick poll or show of hands. Like, who's heard of domain-driven design? Perfect. Keep your hands up if you used it. Some aspects of it. Okay. Some aspects of it. All right, cool. Some of you, yes. And then just, has anyone read the book where the domain-driven design was first introduced? Really? Nice. Yeah, I know. All right, thank you. Good results, I would say. Not that it would change anything. So, for those of you who didn't hear about DDD, so it's not a technology, it's not an architecture, it's basically a methodology or approach to software development. So it dictates the things you should do when you want to build software, like the process, the steps, right? It's technology agnostic. It's suitable, most suitable for like complex problems. Like if you are building some like CRUD app, don't bother with this. If the problem is complex, like that's a good choice. And also backend is the best place where it can be applied. As can be seen by the name, like it's talking about domain all the time. I will explain what it is later. And yeah, it was introduced by the in the book called Tackling Complexity in the Heart of Software in 2003, I think. And I like this title because yeah, it's all about like handling or tackling this complexity which it's created in software when we don't think about it or when we are not careful. And the heart of software is the domain part, of course. Now, like the core idea of DDD, which I really want you to understand, if that was the only thing, I would be happy. The idea is that kind of the real world, which we want to do something in with our software, like solve some real world problems. The real world is already logical, kind of understood, and it makes sense mostly, at least for people who understand it. And then the idea is that if we build the code exactly based on that real world, our code will also be logical, well understood, and will make sense. So that's kind of the magical thing which we need to understand, right? That's the premise. That's why it's called domain, because the real world is we can call it domain. Again, I will get into it a bit better, but yeah, that's it. Now, I try to. It has plenty of patterns and concepts and everything. I try to simplify it as much as possible so I can fit it into this talk. And I think there are three main steps involved when you want to utilize it in your like daily software development job. Like first you understand the domain, you create a model of it, and then you build software based on that model which you created. Then like we went through this journey in our company. We went through this journey in our company, so I will be showing examples from us. In order like to make it useful or logical, I need to introduce quickly what we do. Okay, I will try to stand here. So we in Pipedrive Prague, like our first product was this chatbot lead booster. It's like those little annoying bots or chats which you see on websites, and they pretend they are human, but they are not. And you can click there, like do some actions, and at the end of it, like the website owner will get your data and can like start some negotiation with you, like to perhaps sell you some product or things like that. So it's all like built on those decision trees. So this is the admin interface. It's like a giant tree which describes the steps the bot takes. But of course, that's not the whole Pipedrive. Like the Pipedrive is like a CRM, cloud-based for salespeople, and this is the core part where those salespeople have deals and they basically move them forward. And Lead Booster, our chatbot, creates those deals. Now, let's go into that guide. So first, as I said, we need to understand the domain. What's domain, though? Definition of domain is that it's a collection of knowledge regarding specific subject. So subject in our, or can be anything, like let's say if you are a ticket inspector in trains, like your domain will be checking tickets. How is the sound? Is it, can you hear me? Okay. I improved the definition a bit because we are in software world, so we can make it more specific. So it's still a collection of knowledge, but about like a specific subject around which the application logic resolves, right? So if we say domain here, I mean it's this knowledge about the things which we are solving in our app. So if we are building Twisto, let's say, like our domain is the payment industry, like accounts, what happens when you open an account, there are some rules, there are some processes, what happens when you close an account, and that's the knowledge which I have in mind. It can also be said like what an organization does and the environment it does it in. That's the domain pretty much. Then the domain expert is basically just someone who understands the domain very well. Typically it's going to be, if you are building a sales software, it's going to be a sales person. If you are building something for a bank, it's going to be a banker. And like domain experts are important for us because they will be a source of knowledge for us. So let's keep that in mind. We can call them also business experts. Now, the first step, like if you want to understand the domain, is to sit down with those domain experts, which means really people from the industry which you are working in, like real, like actual people, not product managers, like just those people who work there, and you try to combine like your language and their language. Ubiquitous language is a bit like weird term. They like to use those fancy terms. All it means is pretty much like universal language or ever-present language, like language you use all the time. That's what it means. So this ubiquitous language should describe things like what objects exist in that domain, what operations can happen in the domain, like what actors are there, and things like that. So again, in Twisto example, like an account is typical domain name. We need to, or like a term from ubiquitous language, we need to give it meaning. The output of that can be like a normal glossary, just a dictionary, term and explanation. But DDD is not strict about it. You can use whatever works for you. So for example, in our example, we just used the UI to come up with domain terms. So we took the UI and described it. This was helpful for us. Or we listed all the events, or all the actions which the user of the chat can do, and this became our ubiquitous language. So from now on, you don't see my mouse, but there is respond to prompt term. You can imagine many different or alternative terms for that, like click button, send message, like send data. But now we agreed that it's going to be called respond to prompt, and from now on we are always using respond to prompt. So this is super useful to kind of reduce those misunderstandings which arise from using different names for the same things. And last example, again, UI with some like common names. Another step, if you want to understand the domain, is to break it down. I don't want to spend too much time in here, but this only applies if your domain is so big that it has people like using different terms working with the domain. So again, typical example, in online store you can have a person who's taking care of inventory and then another person who's taking care of shipping. They are using completely different wording, like their work is different, so that's why in our application those should also be different subdomains. Here you also identify like external systems which you shouldn't really code yourself, but buy from someone else. In our situation, like our domain was so simple that we didn't need to do it, so I will just move forward. Now we are moving to the second step, which is the creation of the domain model. I would say that this is the most important step. But first, like again, a little bit of definition. So what's a model? a word modal. So the dictionary says that it's a system of abstractions that describes selected aspects of a subject. The important thing here is that abstractions, it's kind of like shows those selected aspects differently than in the original subject. It can also simplify things, so if there are aspects in the original subject which we don't care about, they are omitted in the modal. And those selected aspects needs to be preserved, right? So if I will go into an example now. So it's very important to know like what aspects you care about in that subject. So as an example, we can look at this. So this is our planet, everyone as we know it, and then a map is a model of our planet. So here with this map, someone who made a decision that they are interested in like the terrain, so they are displaying the mountains, you know, and those kind of things. They are not displaying, for example, countries. This political map is different. It's a model of the same planet, but instead of focusing on terrain, it shows countries. However, there are other trade-offs made in this model, right? So this person who made it didn't care about preservation of like size and distance. If you check it, like Greenland looks pretty much the same size as Africa. In real life, like how smaller you think Greenland is than Africa? Like 14 times is the answer. Based on this, it doesn't really look like it. On the other hand, this map is good, like for navigation. If you want to go from, I don't know, let's say Portugal to United States, you just go like 270 degrees left, and you get there. I mean, in real life on a boat. Then there is a different model where the sizes are preserved, but this sucks at navigation, right? So I guess you get what I'm trying to say. Like, decide what you want to keep in the model, like what aspects of the original system you want to keep and what aspects you don't care about. And then the combination of both words, like sorry for the crappy picture, but if we say domain model, which means the model of the domain, this means that we are taking the real world, the reality on the left, and just taking some aspects from it and creating a model. So what aspects we should take, that's kind of key thing here. So we have some use cases which we want to solve with our application, and in our domain model we should preserve those those things which we need to solve those use cases, right? So we definitely need to keep like things like what data we work there, what operations can happen there, how different actors or objects interact with each other, and so on. In DDD, there's like a guide how to create those domain models. There's like some building blocks defined. That's how they call it. I will go into it a bit later. But now let's look at an example of a domain model. I think that's best for learning. So the simplest one we have, and also the first one, it's kind of now updated because the model needs to evolve continuously. So this is the first version, which is not true anymore, but it was at some point. So this domain model on the left describes the functionality of this chat window on the right. So as you can see, the main object called entity here is conversation. It contains some data which we need to know about this ongoing conversation. Like it has multiple messages, it has multiple prompts, and it has some responses to prompts, right? Also, as you can see, there is respond to prompt operation on conversation, which is the only like action we have in this model. That was the only one we needed at that point in time. And you notice it's the same wording as we had in the ubiquitous language. So respond to prompt is used in the ubiquitous language and also in domain models. That's very important. And other things which are important is, as I said, the model evolves continuously. And like it's not absolutely true, but the simple way how to imagine like what will happen from the model is to imagine classes in the code, because that's what it will become. But again, will be explained a bit later. And also another thing which I want to mention, as you see, this is kind of ugly image. That domain model, like it doesn't use any convention, or well, it does use some conventions, but ones which we made up. DDD doesn't care about tooling, like if you use UML, probably you shouldn't, but whatever you can. You can write it on a paper, on a whiteboard, whatever. Just have that activity to create the model. That's important. There are some like good practices how to create the model. So the absolutely key thing is to work on it together with PMs and domain experts. In our situation, like PMs were representing domain experts because like there isn't really a domain expert in chatbots. It's not kind of an industry or something, so the access to domain experts there is difficult, but our PMs are quite improve it all the time, then make everyone in the team like familiar with it or know what it is, why it exists, and so on, and use it daily. Like when you talk about some new feature, like open the model and then think where this feature fits into the model. Don't just talk about technology or anything, like think about the domain. Another example, just to show you what it is. This is a bit bigger, but still quite small. And again, this is another one, probably the most complex we have so far. This one like shows, or the image itself doesn't show it, but for us, this is an evolution from the very first one I showed you today. So it was super small at the beginning, and then first of all we realized that it sucks in some situations, and second of all, new requirements came, so we needed to evolve it or like to improve it. So that's always gonna happen. And now the last part, which if the model is done correctly, this should be relatively simple. We will take the model and build the software based on it. As I said at the beginning, there needs to be pretty much one-to-one relationship between the code and the model, because the real world makes sense. If we keep that relationship, well, if we did the model correctly, it also makes sense. And then if we write the code based on the model, it will also make sense, if you get what I mean. Like there are some details, like some small ones. I will show some examples. Please remember that you can use any technology for this. Like mostly it's used in Java or .NET for historical reasons. The people who came up with this were Java developers, so that's why most examples are there in Java. We use TypeScript for it, and it works well. TypeScript is good for DDD because of the strong type system. I will be showing some examples in TypeScript. And now I noticed that I already said all this. So let's start with some layers. Like that's not the core thing, but DDD still makes some requirements on how you layer your app. The main one, and I think the kind of the only one which you need to remember, is that the domain part, which represents the domain model, needs to be in the core with no outside dependencies. I mean that the domain part cannot depend on other parts, right? That's absolutely crucial, and only by honoring this rule, you will make sure that the domain part is not compromised or not corrupted by the infrastructure concerns or outside world concerns. Like typically, people make mistake that I don't know, in database they need to store whatever, a date as a string. Just came up with this quite bad idea. So in the domain model they also represent date as string, but it doesn't make any sense. Like for some technical reasons you shouldn't change your domain. You have other layers to care about, like translating the domain to what they need to do with this. Practically speaking, just put it in a separate folder or in a separate project or whatever, and don't let it use other stuff. Again, getting back to those building blocks, we will be talking about them a bit, because the domain model I showed you before, like just a bunch of boxes, those were just entities and value objects and aggregates. There are some other tools we can use, but those entities and value objects are most important, so I will start with them. This is entity, that's the playbook which you saw before. Playbook in our domain represents one chat flow, so that decision tree, that's a playbook. It has some actions, like you can set its name or set that flow, which is again called actions in our domain, and it has some data. The entity is the most common building block you will be using in your DDD apps because it represents things which in the real world has some like continuity, which exists for some time. That's how you can tell it's an entity. Another thing which entity has is a unique identifier. So you need to be uniquely say that this entity is one entity and the other entity is a different entity, even though the data might be the same. Typical example, like an account in your bank, that's an entity, right? You have a bank account open for a long time, you change it, but it's still the same bank account. So this means like it can be mutated. That's an attribute of an entity, and it should have behavior on it. So if you want to change that bank account, this logic should exist inside this entity. But as I said before, there's no persistence behavior in this entity or any other like infrastructure concerns here. Let's say you want to expose it via API, that mapping to JSON or whatever shouldn't exist in this code. That's a concern of something else. In code, super simple, like nothing difficult here, just a class with some like internal state, private state, like you expose what you want to expose. That's it. Like another important thing here is that an entity always needs to be in a valid state. So whenever it's mutated or created in a constructor, you need to make sure that the entity doesn't get into a state which is not valid when all the business rules are taken into account. So we say that the account cannot be open for more than, okay, some better example. Account cannot get into negative balance, let's say. So every time you want to take money from that account, you need to check that the balance will not go below zero. This is responsibility of the entity itself. It never can be invalid state. Very important. Like the anti-pattern here, or like the different way of doing it, which I've been doing like this as well, using that anemic domain model. Anemic means something like thin or things like that, which means you only like define the shape of the data. So here again, example of this playbook, but you notice it's an interface. It doesn't have the behavior on its own. Then this data is manipulated by stateless services, right? You have a service to, let's say, take balance off bank account, and this service needs to check that the balance will not get below zero if some money is taken off. So that's an anti-pattern because you need to copy-paste those business rules across the application, and you can never be sure that this object is in a valid state. Very important. Value object, kind of similar as entity, although different. So this is representing some like data which doesn't have identity and doesn't have continuity. You can replace it with other value object with the same data, and it's gonna be fine. So this is typical examples. Like in our situation, we have a bot profile value object which represents the picture of the bot and name. When we change the name, we just drop this value object and create a new one with the new name. And other like probably better examples are like if you want to represent an address in your domain model, you create a value object which contains the logic related to address, but this address itself doesn't exist for a long time, right? Like it's just existing as part of other entity. When it comes to code, again, it's just a class, but here we expose everything. Not much sense in keeping private state, and there are no setters, so this is immutable. So only you can have some behavior which calculates stuff based on the state. Now aggregate, this is a collection, or we can say a graph of entities and value objects, which make sense to work together. Like when an entity doesn't make sense to exist on its own, we put it to an aggregate with other entities. Typical example again is like in online store, an order has some items in that order, right? Like the product you bought. That item which you bought doesn't make sense to exist on its own. Like there is probably like the quantity, how much of it you bought, the price you bought it for, and so on. This only makes sense as part of the whole order object or graph. So that would be an order aggregate. Aggregate's main purpose, am I louder now? Yes. Aggregate's main purpose is to keep the integrity of data. So you always retrieve the whole aggregate from the database, and you store you persist the whole aggregate. So that's useful when you have some business rules which span across multiple entities. So again, the example of online store, if you have an order, and for some reason some crazy person in your organization came up with a rule that an order can have a maximum of 10 products in it, this rule will be like enforced in this aggregate. Then, like now very quickly, like there are domain events. Like when something happens in your domain, you emit an event which you then handle in some handlers. Very often you send those events also to outside world so that other domains can react to it and, let's say, synchronize their data. Very useful. Domain services, just a stateless class which interacts with multiple entities. Sometimes you will not be able to choose one entity where you put your logic, because that's the default way you do it. If the logic interacts with multiple entities, you create a service. It's just a class, so I didn't even include an example of it. And factories, same thing, encapsulates logic for creating entity. Repositories are more important or more interesting, I would say. As I said, the domain needs to not know anything about infrastructure, and the database is a typical example of infrastructure. Like almost every backend service interacts with a database, and we use repositories to create like a, how to say it, like a barrier between domain and the infrastructure. You just define the interface, what it needs to do, and implement it, and then from the domain, like you just call save, and it magically happens. Here we also see like an implementation detail that we dispatch those domain events from inside repository once the entity was persisted. And the last thing from code, like I call it bonus because it's not that building block, but still very important when you code it. Like make sure you don't connect stuff in your code which cannot be connected or shouldn't be connected. So here, this first image, what I'm trying to say with this is that your types for representing your API schema, types for representing your domain schema, and types for representing your DB schema should not be the same types, right? Because if you make it the same types, again, the domain will be corrupted eventually. Even though you start at the beginning, the domain can be one-to-one with the DB. It's not always going to be like that, so you always want to start with separate types. And this second example shows that you can like build the whole like anti-corruption layer when you need to talk with some external system and do some like complex translations between their data and your data. Again, don't change your model because some other external system works differently or uses different terminology. So this was the guide, simplified. Please notice this here, but I think it shows the idea of it. And as closing words, I want to say that just an idea for you. So next time when you build a system, like consider starting with thinking about the domain and the problem which you are solving, instead of diving into technology discussions and choosing frameworks and libraries and so on, because that's what I think we tend to do. And also, like, if you make your code follow the rules of real life, it should be simple. And at the end, the quote from Martin Fowler, like the main thing is that the code can be understood by humans, and hopefully if you follow the DDD rules, the code can even be understood by non-technical humans, maybe, because it uses the real-world terminology and so on. All right, that's it. Thank you very much.
Alright, Jakub, I will just shout because it's easier without the microphones. So it was the least thing that we expected, that there will be interference with the microphones and some construction going on in the upper floor. But still, if you have any questions for Jakub, please use Slido, #Backendisti.
Should I show it here?
Yeah, it would be great, but still, you can open your phone and ask the questions, because you can, in that way we can vote, and Jakub will answer them. Yeah, now I have wired microphone, so it sounds much better. Yeah. All right, so still no question.
They will appear here.
Yeah, they should appear here, so.
Book recommendation. So I would not recommend starting with the original book from 2003. As someone said, it's super dense and super difficult to read. The guy is kind of boring. Like if you look at his presentation, oh my God, that's difficult to survive. But his book has been simplified. Like it's called Domain-Driven Design Quickly. It only has 100 pages or so. So I would recommend starting with this. Yeah. And it's free to download. You just need to give them your email or something and you can download it. Domain-Driven Design Quickly.
All right, any other question? Cool. How do you deal when one entity belongs to multiple domains?
So this never happens. That's two entities. You will be kind of tempted to make one entity appear in two different domains, but it's not the same entity. You are missing some difference between it. One domain is always like looking at that entity in a different way than another domain. So try not to do it. You can share some code, like some library code, like I don't know, some logic or whatever, but it's a different entity. Or if it's the same entity, maybe it's not two different domains, but it's the same domain.
All right, we're gonna wait for a few seconds if any other question appears. So how do you set up mutual language between programmers and business when it's highly technical?
Two aspects here. If you are building something like I don't know, a load balancer or a router or like really highly technical piece of software, then I would suggest that maybe DDD is not the best approach because exactly you don't deal with domain rules or domain terms. You deal with technical constraints and technical rules. So I would say don't. If another approach, like another situation can be when it's not a technical domain, but still you say that it's highly technical, then I don't know what it means. If someone can clarify maybe, or what was the first example which I mentioned, what you meant? Probably.
Yeah. So do you find yourself writing a lot of boilerplate code?
Yes. It's like we are just beginning, so we don't want to invest time into creating some, reusable abstractions. We would rather like repeat some code, like duplicate. I don't think that's the end of the world. And when we see some common patterns, I think it's going to be easily possible to abstract it away to a reusable code. But yes, like your DDD code base will most likely be bigger than your non-DDD code base. It's like one of the possible downsides.
So where do you store your models, the diagrams, so that business people use it and it is updated, probably regularly? Did you try to generate it from the code?
We store it in the wiki, so everyone has access to it. We don't generate it from the code because often like the diagram is ahead of the code. So first we like change the diagram, then we write the code based on it. But if you mean like having some kind of how it's called, like some specific language for designing those diagrams, that would be quite cool. But we don't use it. So it's just, yeah, it's a bit bad what we use. It's draw.io, like you drag and drop with mouse different things. And that's what we use.
Do you apply CQRS and event sourcing with DDD?
We don't, but I would love to get there one day. I think it's like next level, basically. Like it adds so many benefits, but also so many. It's kind of difficult to do right, so we don't do it now. but I think we will do eventually, especially CQRS. Event sourcing, I don't think we have a good use case for that.
Where do you store your models? That was already answered. So what's the scale when it starts to make sense to use DDD?
So we can look at the scale from different points of view. Like if it's some kind of prototype you want to, okay, no, sorry, few aspects. If it's like some kind of technical project or not a core project to your business, and you just want to prototype something, write some script or something, don't use it. If it's just one person working on it, or let's say two, again, probably not worth using it, because a lot of benefits come from shared understanding of the domain, and it simplifies communication. If it's one person, like, or two, the benefits are smaller, basically. When it comes to the size of the app, I don't know how to answer. I think we are on the lower end, like what you saw, that chatbot, that's on the border of like being too simple to use DDD. But on the other hand, we expect it to grow, so that's why I think it was a good choice. In general, like if it takes more than a few months, I think it's already good, big enough to use DDD.
How do you structure your TS projects?
I would show a screenshot, but let's not connect it. Like basically, we have a folder for domain, a folder for infrastructure, and folder for application. These are the main three layers which we use. Domain, as I was talking about, like contains those domain concerns. Infrastructure contains everything like from persisting data, caches, the API controllers. No, now I'm lying. API controllers are in infrastructure, so that's the fourth thing. But you know, the setup of the service is in infrastructure as well. And in application, it's just use cases which translate what comes from outside to what domain expects. Like if you catch me afterwards, I can
we'll
show
have
you.
a short break, so
Yeah.
you can catch up with Jakub, and maybe he'll show you the screenshot.
Yeah.
So did the transition to DDD make your UI better?
No. Like it made the UI code better probably, because even though we don't follow DDD there, we use the same terminology there. So this already helped, because it was kind of a mess. But I would say in general, no.
All right,
I don't know
maybe last questions, because people are already looking for the break, I think. So is it right that the entity needs to be mutable?
I can imagine entities which are not mutable, but it's most common to have entities mutable. Like, but again, depends on the what you need to do with it. Depends on the use case and the business rules. If this object needs to exist through time, like it exists basically for a long time and is persisted, that's already an entity and it has an identity. The question is, like, if it's not mutable, there's probably not much business logic in it. Depends whether it even is worth like creating an entity without much business logic. But no, it doesn't need to be mutable.
Okay, so I think for the other questions you can catch up with Jakub and he will happily answer them. And right now we'll have a short break for about 10 minutes. There's some refreshment in here, and also feel free to take anything from the fridge. We have some beer and there's also some non-alcoholic beer and some Coke. So we'll meet here again after 10 minutes.
Thank you.
Thank you.
please take your seats. We are going to start.
Tady si sedí, no. No to asi obávám, že nebudeš moc začít. Já takhle se protáhnu, já ti to tady narovnám. Promiň. Tak, dobrý. Okay, this time we changed all the wireless technology with the old good cables, and it seems better, much better. So let me introduce Victor. You know him, and he likes to play with small toys that are hard to see, hard to be seen. So Victor, tell us about hacking IoT.
Okay, so is it working? Yeah, it's better. So I'll maybe wait a bit. Can you hear me clearly? Or is it just me talking? Because I can't hear myself, so maybe it's pretty good. All right, so as Petr already said, I'm Victor, and I haven't put any about me slide there, so I'll just tell you about it. I'm a CTO at Twisto, and for those who don't know us, Twisto is a payment for, is an app for your daily payments, and we allow our customers to pay either now or pay over time, and we offer additional features such as personal finance management in order to help you better understand where you're spending money, and what are your main expenditures and stuff around that with just the simple taps in the application. But today I'm here to talk about Internet of Things, which is a whole segment of different areas, coming from industrial applications to home and building automation, smart home. A lot of sensors can be also perceived as Internet of Things. And I started with automation a few years ago without any knowledge about hardware. So today I would like to share you my story and give you a brief overview of what is possible to learn in your free time in a quite short time period, and why I find the process quite entertaining. So I got the first idea of a hardware project when we moved to our new offices with our company, and we got this strange looking gate in front of the office, and yeah, in order to open it you would just have to use the key fob and press the button, and the gate will open. But for that to work correctly, we would have to buy key fobs for every employee, and they would need to carry it around with them just to open the gate every now and then, because you don't open it every day. Usually the first person that comes to the office opens it, and the last that is leaving the office just closes it down. So it would be quite impractical, but yeah, that's probably what a normal person would do, just buy a bunch of key fobs and distribute them to all the employees, and it will all work as expected. But that's not really my way of doing things. So I was thinking about a better solution to that problem. And I, of course, disassembled the remote control and was looking for a way how to develop a solution to help us distribute it better. So I dedicated my whole weekend to finding solution, and this is what I came up with. I came up with a small Slack application or Slack command, which opens the gate when you type /gate into it, and it pushes the button, and that's basically it. So it allows all the people that are in our internal Slack to open the gate quite easily without having to wear a key fob or anything on the keychain. So probably you're wondering how I did it. So back at the time I was already familiar with Raspberry Pi, so I lied a bit that I didn't know anything about hardware, but still it was a really easy solution how to do that, and I just replaced the original push button of the remote control with a transistor and hooked it up to the Raspberry Pi. Raspberry Pi is a fully fledged computer, really small one, but still a fully working one with a Linux operating system on it. So you can program it in almost any language you want, and in that way you can control external devices such as these transistors and switches and everything, almost everything you can think of. And I also hooked up some additional transmitter to it to just make the signal better. I just bought it from eBay. I haven't had any idea what that thing does, but it helped, so I hooked it up to that. And so now every time the Raspberry receives the command from the Slack, it just pushes the original button and thus opens the gate. So what is the most interesting part for interacting with IoT on the Raspberry Pi is probably the GPIO interface, or general purpose input-output, which can be controlled programmatically, and it can turn on and off individual pins. So you can just control devices like a transistor that was shown in the previous picture, but it also allows to use certain protocols that allow you to communicate with external devices. It has a really low entry barrier, it has great documentation, and although the previous setup looked quite messy, when you put it into a simple enclosure, you can even power it up from your router, and it looks almost like the device is factory made and can be operated from your desktop. So yeah, that was one of my first projects, and then I was digging deeper and finding also about some of the disadvantages of Raspberry Pi, because yeah, I really like it. It has a lot of benefits, but also some small disadvantages. And the first one, which is probably the biggest one, are the power requirements. When you need to operate it from a battery, it's not very efficient because it's a small computer. It will be able to run from a power bank for maybe a few hours, but then that's not something that you would use for a remote operation or something that needs to connect to the internet quite often. It also has the operating system complexity, which is one of the biggest advantages, but also biggest disadvantages, because it's running a full operating system. You have to keep it. You have to do the updates regularly in order to keep it secure, and it also takes some time to boot. And there is additional complexity around the whole operating system as such. There is no wireless connectivity built in. You can obviously use USB dongles, but they're not very reliable, and they add additional price to the whole project. So you would need to buy external device in order to hook it up wirelessly. But it has a wired connection, so you can at least connect it using the cable, and it will work perfectly, but that's again not for every use case. And probably the last disadvantage is the price. For a single device, it costs about 35 to 40 euros for a regular Raspberry Pi. There are some Chinese rip-offs which are cheaper, but still the price is quite high. If you're thinking about running multiple devices and hooking up multiple sensors. If you're thinking just about one device, it's completely okay, because you would invest a few amount of money and it will run perfectly. But when you would like to connect multiple sensors, multiple devices, the price will rise up pretty quickly. So you may have noticed that the hardware design is quite different from regular software programming. And in hardware design, you're dealing with physical objects, so you have to think ahead and do the proper planning before you start implementing something. So unlike in software, when you're not happy with the code, you can just rewrite a few lines of it. It's not that easy to change something that is already implemented in the physical world, so it cannot be changed at least that easily. And there are also some other restrictions that come into place and you should take into consideration, and these are the resource limitations like CPU power and memory, but also that flashing firmware takes some time, so you probably won't change the code quite really that often, just after a few changed lines to see what is the difference. So at least for me, visualizing the project from the beginning brings much more enjoyable experience to the whole development, because it's like for me, is like an escape from a real software world where you just write a few lines of code and test it out and then do the changes and do this process repeatedly. It's not possible in the hardware, at least if you don't have some simulators or something like that. And that means a different way of thinking and a little bit of freedom to the process and to the whole idea behind it. And that brings me to my next project. And some time ago, I found out on the internet that you can compost your organic waste instead of throwing it out. So as I'm something that I like to care about the environment, I find that idea really interesting. So I bought one of these composting bins and started putting all kitchen scraps, mostly fruit and vegetables, into it. And how that basically works is that it utilizes worms living inside of the bin. They take care of all the organic waste and reduce the original amount of the waste to about 30% of the original. So they get rid of the 70% of the waste, and they produce a thing that is called castings. It's just a fancy word for the worm's poop. So that's mine. Really? It's not. It's someone else. But anyway, I don't know why it's on the microphone. But it wasn't my phone. All right. So yeah, the worms as a byproduct produce the castings, which is quite nutrient-rich compost that you can later use for your plants. And as I have a small herb garden on my balcony, I was thinking about how to make the compost the most nutrient-rich as possible, and that for that I would need to prepare the best possible conditions for the worms living inside of the bin, and for that I would need some monitoring. So yeah, definitely. So I came up with a list of requirements for my next project, and one thing that I figured out is that I would like to measure temperature, of course the humidity, and also pH level, because that also influences the quality of the final product. I didn't want to run any cables inside of the bin because it's in my kitchen, because when done properly it doesn't produce any smell, so the worms that just take care of the waste before it starts smelling. So yeah, it had to be battery powered, and I would like to, and I also wanted to show the values on a display, so I didn't have to open up some application or look up on the web what are the actual values. So with that came a really new challenge for me, because battery powered devices were really new, and the whole concept it was something that I didn't know nothing about. So what I found out is that for the battery powered devices to work correctly, you have to turn off everything that's not currently in use, like all the external sensors, displays, and everything. Also put the microcontroller to sleep and only wake up in periodical intervals just to measure something, report the data over internet or display it on a display, and then go to sleep. So you can see here a small loop, an example of how that device really works. And yeah, at first it does the measurement, wakes up only for doing the measurement and reporting data, and then again goes to sleep. And with that, you can run your device for quite a significant time depending on the battery, and even when it wakes up for, I don't know, like 500 milliseconds or a second, it can run from a single battery for like a year. For the display, I was thinking about something different at first, but then I figured out, well, I have an e-reader and it's using e-ink display and it's a cool technology. So I was researching on the internet and found one of these on AliExpress. So I bought one, and what is cool about the e-ink is that it consumes energy only on refresh. So you just power it up, you refresh the display, and then it goes to sleep. It doesn't consume any energy, and the data that is displayed on the display just stays there. I also created an enclosure for that, which is 3D printed, so that I could put it on top of the bin, and it looks almost like it's part of the original product. When you're thinking about the device or the best go-to microcontroller for low power, There are a lot of different opportunities, some of Arduino compatible devices, some from other different platforms, but my favorite go-to microcontroller is Node MCU or ESP8266 because it has really low power operation, only 100 milliamps in operation and only 15 microamps in deep sleep, which is great because it's sleeping most of the time, therefore it doesn't consume that much of an energy. It has onboard Wi-Fi, which can serve both as an access point and as a client, so it can report data over Wi-Fi protocol, and it has a really compact size, which makes it one of the best options for custom PCBs because it doesn't consume much of a space. And probably the biggest advantage is its price, because the chip itself costs about $1 when you buy a single one, but when you buy in bulk and order 100 pieces from some Chinese manufacturer, the price gets even lower. And that's when circuit starts getting complicated. Well, when you're designing a more difficult project than was just opening the gate with just 2 transistors, you pretty quickly realize that there's a lot of cables going on and they need to be connected to each other. And well, you can definitely solder that thing into place on some prototype board and put all of this into enclosure, but it wouldn't be very practical, and after some time you wouldn't be able to make any changes to it because you would have no idea how that thing worked. So what I ended up with was drawing the circuit on a piece of paper, all the connections and how it looks like, so that it helps me find some errors in the process or make future changes. But then I thought, well, I'm already writing it on a paper. Why wouldn't I use some design tool that is made for that specific purpose? So I was researching a bit, and I settled up with KiCad, which is a design tool which is open source. It's available on most operating platforms. And it allows you to design both the circuit and also the final PCB or printed circuit board. There are also some additional options on the market. Probably the most notable one is Eagle from Autodesk, which is free in some, I think, for some small boards. And only if you're using it for commercial purposes, you have to pay for it, or if you're designing bigger boards. And for professionals, there's this Altium Designer, which is really the ultimate tool, and the professionals are using it for designing motherboards for PCs and completely different things than just some prototypes and toys that I'm doing. So yeah, I designed the complicated circuit, and now it doesn't look that much complicated at all. And then I was thinking about how to move it to the final product. So all those connections that are reflected on the picture on the right, the wires can be implemented on the PCB as traces. The traces are the green and red parts on the image, and they represent the copper traces that are connecting all the components together. So instead of the wires, we're using traces on the PCB. And the PCB process, or the design process, consists of 2 parts. As I said, you first design the schematic, and then you need to move it into the final product, into some kind of footprint, and assign all the components into place on the board, and draw the connections between each of the devices. What is great about the process is that the design tool helps you with the connections. So it knows everything about the circuit, so it also knows which part should be connected to which net. So it's almost impossible to make a mistake in that way, because there are some electrical checks that it is doing on its own. And when you're ready with that, and then you have some brief prototype of the board and how it should look like, there's the design validation step where you can print it out, and when you do it in the same scale as the original, you can just match all the components and put it on the paper and see if they're of the correct size. And you can also print the cutout and put it inside of the enclosure that you've selected for the specific project. Some of the tools even offer 3D visualization so that you can look how the final product would look like even before you send it to the manufacturer, which is a really nice feature because you can rotate it, look for all the traces if they're connected correctly, and have a general idea how the product would look like. And then obviously the next step would be to send the final design to the manufacturer, and there's a lot of them that you can select from, with the cheapest being from China. Some of them even offer 5 pieces of the final board or PCB for just $2. Yeah, they're really cheap. The quality is like okay. It's not the best possible. You can pay for additional like surface modifications, but still it's pretty cheap. But it takes quite some time to deliver, so probably around 3 weeks to manufacture and deliver the final product. There are also some manufacturers in the European Union, but these are mostly suited for a professional product or a batch production because they have all these electrical certifications and everything that is needed for the final product, so they cost a lot of money. But yeah, they're really great quality, but I never tried any one of them because of the price. And there's also one manufacturer from the United States, which is really noticeable and known on the market. This is called Oshpark, and they probably offer the best price/quality ratio. But the downside is that they collect all the boards from individual people and put them on a bigger board so that they make the manufacturing costs lower. And in that case, it takes some additional time to manufacture. So you would have to wait a bit until it's manufactured and sent to you back home. So when you receive the final product from the manufacturer, it looks exactly like this. And then all you have to do is to put all the components on it, and it should be working, right? So you just put one by one, solder all the components on the final board, and then you can upload the firmware and put everything into its final destination, and it should be working. Yes, and it was working for me with this specific project for first 3 weeks. But then it all of a sudden stopped working at all. So this was the moment when I realized that most of the time you don't know what you really don't know. And this is the final product. And I was looking at it and it wasn't reporting any data, so I tried to restore it. I tried to disconnect the battery, and it wasn't reacting at all. So I was looking closer and I put that under a microscope, and I found out there's some corrosion going on, and probably some of the moisture from the composting bin got inside of the circuit and destroyed it altogether. So yeah, with that project I had to start all over again with a different design because of the different enclosures. So I looked for some enclosure that is IP protected and it's completely waterproof. And I had to design it all over again. So, and ideally with better components because I already had some modifications in my mind that I could incorporate into the original product. But that's probably the usual design process with many hardware parts or components. And it's not very unusual on the market because you find all this information in forums about other people, how they're thinking about the design process. Because developer cannot be happy with a bad code, right? So it's the same with hardware. You usually sketch the prototype, design it, or source and order all the components. And while waiting for the components to arrive, you find out, well, I could have implemented something better, or that you found a new components or something, and you make your previous shipment obsolete before it even arrives. So then you source for new and better components, and do the changes to the design, and then wait for the components to arrive. And then you begin assembling the prototype, finally. And during the assembly process, you find out that one of the components is dead on arrival. And that has to be the component that has like 2 weeks shipping time. So yeah, in order for to be really sure that it will work, you order like 5 times the component from different suppliers, just to be sure that it will work once it arrives. And while waiting for the shipment, you go through some forums on the internet. I find a completely new and definitely better idea for the whole project and how it should look like. So you place all the parts in surplus bins and start all over again from the step number 1. So yeah, there's a really thin line between yeah, as I said, you're not always happy about the outcome, and I have some projects that are working perfectly, but only the feeling and only my knowledge about, well, it could have been better, or that it could be 1% more efficient, that bothers me, because, well, if it's in your code, you can just refactor it and it's okay, but you cannot do it in a physical project like that. But that's probably something that is really usual, and that's also probably the reason why they release new phones every year, because they discover new approaches, new components, and they make it better every year, and they can make a lot of money on that, right? So yeah, sometimes when you receive the package, you don't show signs of any happiness, because you already know that the product won't work at all. And some projects even take much longer time, and this is one of the examples of a project that took me more than a year, and it's still not finished completely. So it's a self-watering project for watering the plants on my balcony, and yeah. So yeah, that project is the first one that is consisting of multiple boards, and I have some humidity sensors inside of each pod. I have it here on the slide. So yeah, I have humidity sensors inside of each pod. I have one water pump controller that you've seen here on the video, and I have one control board which is hooked up to the solar panel, I don't know why I did that, but probably it was too easy to do it without it. So I decided, well, it would be cool to power it up from solar battery, but it brought additional challenges to the project, and that's probably the #1 reason why it's not completed yet. But but yeah, I just did that because I like playing with stuff, and for me the process is more important than the final outcome. So yeah, that's probably the main reason. But yeah, as I said, this is the first project that I used and required multiple boards of the same type. And usually when you're assembling, is it playing? No.
So
usually
just put solder on one of the pads?
Yeah, so I should mute it probably. Maybe I can't. So yeah, usually the soldering process looks like this, and you have to.
Okay, and do the same thing we did with the controller. Just put it on there.
You assign all the components on the board, and you solder them one by one. And this guy is really good with it, so he's like 2 times faster than I am. So yeah, but I think you get the general idea how it looks like, and that it's a sometimes really painful and slow process, especially when you're dealing with small components. So yeah, leg by leg, you just solder all the components into place. And this was the first time I was wondering, well, how are the big companies able to manufacture all of the boards in such a fast pace? And yeah, I found out this is the answer. They're using these kind of machines. They're called reflow ovens. They have a lot of cool features like vacuum chambers. I don't know why, but they have them. And what they do is that basically they're just following some kind of reflow profile, and they are applying even heat to the surface, so that all the components solder itself on the board by just activating the flux. So it just pushes them on the right position, and they get reflowed in this way, so they are positioned in the final where they should be. In the first process, you just have some kind of template, which is a thin stainless steel plate or aluminum, doesn't really matter. You apply a solder paste on it, so that across the template, so that you only have the solder paste where it should be on the pads on the PCB, and then you put it inside of this huge oven, and it will reflow it, and the outcome is the final product. So I was looking about a smaller version of that thing, and I came across AliExpress, and I was researching some of the options, and I almost even bought that one, but then I started reading reviews, and some of the people said, well, this thing is good enough, but it's not applying even temperature or even heat on all the parts of the board, so sometimes the result is not 100% perfect. So, well, that wasn't really for me. So I decided that it would be better to do it by myself. So I bought original convection oven, and before that I researched a lot of articles about how to make your own reflow oven. And as you see here, you can bake a crispy chicken in it, or you can use it for baking PCBs, doesn't really matter. But for PCBs, it's more challenging than baking a chicken, because you need to keep a steady temperature. And it has to follow the specific reflow profile as was shown in the previous picture of the solder paste. So I needed to tear it apart and add a lot of additional insulation just to keep it from the temperature from dropping. So the original oven was consisting only of a really thin layer of, I don't know what it is, aluminum or something, and it was dropping the temperature really rapidly. So I added additional back cover filled with a ceramic fiber blanket so that it keeps the temperature and it's warm enough. And then I added additional insulation to the inside and was thinking about, well, I should measure the temperature and see how it looks like. But remember, we're still baking PCBs and we need to keep the temperature steady, and it was not enough. So I was researching where probably I should add additional heating element inside of the oven to the oven so that it boosts the temperature more quickly. So I was looking online for the possible options and found out that the easiest option would be to buy a second oven of the same type, take out all the heating elements, I put them inside of the first oven to make it twice the power. And I also bought some additional heating element that I put on the bottom. And yeah, that should be quite sufficient. But then I needed to control each of the heating elements individually. So I wired a bunch of solid-state relays in order to, because in the original oven, when you're baking chicken, you just put it on and it bakes. And you can't control the top element and bottom element individually and keep them at different temperatures. So that was not perfect for the PCB, so I had to hook them up individually. And I also put a thermocouple, that is the thing that is hanging from the wire, which measures the temperature so that it can easily follow the profile, and you can programmatically control the heating elements to keep the temperature steady. For that thing, this was probably the first place where I decided I should look for a final product and not do it by myself. And I found this controller, which was by the way also on Kickstarter, and it's made specifically for the purpose of custom-made reflow ovens. And yeah, really, there's a huge amount of people that are doing this kind of things. It's not only me, even though it might look like it, but it's not like that. So yeah, and because of the recent changes and some regulations in the European Union, we can no longer use the leaded solder paste, and we have to use lead-free, which requires higher temperature, and that means it's much more difficult to follow the reflow profile. But still, with all the insulation and with the heating elements, I was able to come up with this. And with the green dashed line, you can see the original reference profile that I had to follow for it to work correctly. And the other lines are the results of my oven. So I just prolonged a bit the soak phase, which is the phase for the flux to activate, because I don't have a professional grade PCB, so it's better to give it more time to accommodate to the temperature. And but apart from that, it's following the reflow phase pretty perfectly. So then, all you have to do, just to prepare the final product, is that you apply the solder paste on the PCB using the template, using the stencil, and then you place all the components one by one, but it's much easier because you're only placing them and not soldering them. It will be soldered in the oven. So here you can see one component assigned to each board, and it's much easier because it doesn't really matter if you're assigning the component to one board or 6 of them, because you go one by one, and it's a quite easy process. And then you put everything into there's a different project, but it doesn't matter. Then you put it into the oven, and once the reflow phase is finished, you can take out the final product, and if done correctly, it should be working. So yeah, that was exactly the case with this moisture monitor that I designed. By the way, I have it here with me, so I can pass it over so you can have a look. So I probably shouldn't move that much. So yeah, one is the final PCB, and the other one is with the components assigned, and it was designed to fit exactly into this small enclosure, so that it could be battery powered. And with this single battery, it can last for a whole season or about 7 months, because it's waking only once per hour, and measuring the moisture and reporting it back. Yeah, I also added a charging circuit, so that after the season ends, I take it inside, and I can charge the battery and have it report and have it working all again. And it also reports the battery state, which is a nice feature, because I don't know if the battery is at like 30% or 100%, or what is the current status. One funny thing though, after I finished the reconstruction of the oven, I received this message from Alza saying if I would like to buy additional insurance or, I don't know, replacement policy for it. So I was thinking for a while, well, I've made it better, I added new insulation and heating elements, so probably I should buy it, but then, yeah. No, I didn't went for it in the final place. And I also have a live demo. Nope. Okay. There's like only 50% chance that it will be working, because you know how it is, especially with hardware. But this thing, I have to use my phone and turn on the hotspot. And here I have the final product that connects to my mobile phone and reports the current status. And after a while, you should be able to see, yeah, it's already reporting. So now I have this soil moisture sensor that is put directly into the soil, and it works as a capacitance sensor. So it's really touchy, and it's in that way it's monitoring how much water is inside of the pot. So now here this is a Grafana, which is displaying all the values, and when I put it inside of a glass of water, which I don't have here, if you will assist me, I can maybe just touch it, and it should report a different value. It will be much faster. We'll see.
Put it on the laptop.
No, not on the laptop. Is it reporting something? Did the value change? No, not at all. Maybe can you hold it? No, not this thing. And yeah, cool. Yeah, you see the change in the value, and then when I put it out, it should just drop back to the original value. So yeah, you probably get the concept of it, but with the data, it's really easy to set up something like that. It took me, I was creating it yesterday. It took me like 30 minutes with all the Docker containers and everything. And when you're yeah, this is for me. Enterprise. Yeah, for me, this is the easiest part, right? Maybe for some of the hardware designers, the most difficult part would be programming the software, but for me it's the easiest one, and the most difficult one is designing the product, because I don't know anything about it and I don't have all the knowledge that is required for that. but yeah, it already fell back to the original value. So fortunately the demo worked. But that's not everything, and I'm not the only one in our company at Twisto who is really interested in IoT and all of the projects around it. And one time we were discussing all the possibilities and how we are still battling about free toilets in our office. So we were thinking about a solution, and imagine that you wouldn't have to wait for a free or look for a free toilet ever again. Imagine a Slack command /toilet that will show you. Yeah, that will show you the status of each toilet that you have in your office. It will show you the time for how long it is occupied, and you can even use /toilet notifying the number of the toilets to be notified once it becomes vacant. So yeah, pretty easy, and I really came up with a solution for that, and I was researching for a while how to actually detect the presence in the toilet, and I found out the solution. And one of my colleagues also designed a custom printed enclosure for that. So yeah, so smart should monitor. That's probably how you should read it, and yeah. So yeah, we came up with a really fun project. It's not yet completed because the software part is missing. The hardware is already done, but nobody had the time to implement the actual Slack command, which for some people would be the easiest thing. But it's also the most boring part, right? You have everything else ready, and it's reporting all the values. So maybe sometime we'll just finish it. So yeah, that's pretty much it. I hope we found some of the possibilities interesting. I've hoped that I brought the inspiration, because I was really able to learn a lot of things along the way. The IoT and the whole hardware development has a really minimal entry barrier. So you can start, even when you get back home, you can start researching and doing something, and it's really a lot of fun. There are a lot of resources online. You can always search for either IoT or Arduino or Raspberry Pi, and you'll find a lot of it. There's a huge variety of boards and sensors, and you can think of additional use cases that can be quite interesting. But I also think that it's really useful knowledge to have, because you start thinking about how physical products, I don't know, like this work, and you can already think about the concepts and what is behind it. And there are some real-world examples of people tinkering with hardware. Think of an I don't know, escape game, where they design a lot of custom products to just interact in the game. Or I have friends that have a small beer brewery, and they have a lot of sensors in there just to help them automate the process. It's a small-scale brewery, but still it's a lot of fun to play with it and find the opportunities for new projects. So yeah, thank you very much, and if you have any questions, please use sliding.
Have you ever tried to create your own PCBs by ACID and photos?
No, not really, because for just $2 and buying it from a Chinese manufacturer, it was a much easier way to do it. Yeah, the final product looks much better, but yeah, I can.
Even the poor quality is better than make it now.
Yeah, definitely. But I should probably put it here. Just a moment. What are colorful things on the GPIO pins on a Raspberry Pi? I think this was just in the original picture, where it was describing the functionality of each pin in the documentation. I don't think they are colored on the original Raspberry Pi, on the hardware part. So but I had some kind of a connector attached, so maybe it had different colors of each wire, but that doesn't mean a thing. That's just a connector, and the wires are going directly to the external components. Yeah, that one is right. When I was thinking about back then, when I was designing the product with Raspberry Pi, it doesn't had any Wi-Fi connectivity. The newer models do have it. Which internet resources or books would you recommend to absolute beginners? I would start with reading the tutorials on Arduino webpage, because that's probably closest to professional grade microcontrollers. And I haven't read any book about it. There are a lot of books about electronics, but I found them really difficult to read, because there's a lot of information that you don't really need for projects like this. You can just look for the resources online and found the solution to your specific problem, rather than learning a lot about how electronics work on the inside. It's definitely for the better to have some overview of how things are working, but you don't need any deep knowledge in order to design a PCB or do something like that. What people close to you think about your hobby, and have they ever tried to intervene? They didn't. I hope they find it cool. No, to be honest, it looks like it takes a lot of time, but it's not always the case. I just spent a couple of weekends designing something. It can be done pretty quickly, and most of the time you're just waiting for the final product to arrive. So you design something, you put it, you send it to the manufacturer, you source the components, and then you have 3 weeks of free time, and you cannot do anything with this project unless you start with something new. But yeah, so it doesn't take that much time as it might look like. Are your projects open source? Yeah, yes, they should be, and I think there's also on the PCB that I send on the other side there should be a GitHub page where you can look for it. I don't know if it's all. I haven't checked if it's already there, but it should be. What is the principle behind toilet occupancy detection? That is an interesting question. We are thinking about, or I was thinking about different solutions to that problem, and the first one that came to mind was detecting if the light is on or off by using the light sensor. But if the light on the toilet is on, it doesn't always mean that the toilet is occupied, right? Someone could have just forgotten to switch off the light. So that wasn't the best case. The other case, the other option would be to use some kind of proximity sensors, like those ultrasound that you can find on the internet. But these look pretty weird, because they look like a camera pointed towards the seat, and it's not probably the best option. But the final solution that I came up with was using a magnetic read sensor, which is a mechanical switch that switches in the presence of magnetic field. So if you have a switch and a magnet, and when the magnet comes close, it switches the 2 contacts, and the circuit activates. So I drilled a hole inside of the deadbolt of the door, and on the other side I put the switch, so that when you lock the door, it actually brings the magnet closer to the switch and activates the circuit and brings the information to the whole thing.
You were drilling holes to the toilet?
No, only a small hole to the deadbolt, and then I put a magnet. I think there are neodymium magnet inside, and I didn't have to glue it in there because it was holding by the magnetic power, so it was a really simple solution to that problem. Are you developing any IoT devices for Twisto? Not yet, except for the toilet thing. What is the smallest PCB you can make solder at home? One, in terms of size, surveillance purposes, and second, energy consumptions. I think at home, when you have a reflow oven like that, the size of the components is no longer your concern. because you can, if you're able to, by using tweezers, put all the components on the board, and if you have hands steady enough not to mess with other components on the board, so definitely not for someone with Parkinson's, but yeah, but yeah, if you're able to do that by hand, there are no limitations, and it's mostly about your design and about the traces on the PCB itself, and most probably the whole circuit. So if the circuit is too complicated, it needs to have additional components, so it will make the size bigger. But there are really small MCUs that you can use for those purposes, and some of them are even smaller than a fingernail. And energy consumptions, still it depends on the MCU and how often do you wake it up. All right, good book, Radlavo ty jednočipy. Some free book from, yeah, that one is a nice one. I think it is from Arthur Dent. Investment opportunity.
Definitely.
Yeah, is it not possible to order PC with all components already soldered from China? Yes, that is possible, but the price is quite high, especially if you want only a single part. If you have the prototype already working, and if you're thinking about producing the thing in scale, then you can order multiple final products, and they will do it all together on your behalf. But I'm not sure about the quality of the assembly. I would probably, for something production grade, I would probably look for the European manufacturers, and they can, of course, do it on your behalf. Okay, I think that's it. So thank you again. And now we'll have an additional break. There's additional refreshment, I think, and we'll meet here in about 10 minutes.
Please take your seats. We are going to start. Thank you.
No.
Jo. Jo.
Zapni?
No.
Jo, super.
Lepší.
Jak se jmenuješ?
Josef Starý Fojt.
Já jsem si říkal,
Je to divný jméno. Asi ne, asi ne.
So, next presentation will be from company Muse. Do you know Muse? Raise hand. Muse is a Czech company that is growing really fastly.
Yeah.
And we are going to have a presentation about zero downtime migrations. Josef Starých Fojtů.
Thanks.
Go on.
I guess. No. Jako ten Mac nějak zaregistruje, že se něco děje, ale blbý.
A nemáš tam moc vysoké rozlišení? Zkus dát nižší rozlišení. Ale dej tam nějaký 1024 nebo něco takového. A to je Full HD.
We can try this one.
To je asi moc.
Ne, ale Full HD by to mělo.
Ty jsem zape. Víš.
No co?
Lenovo, to nemůže, to je ostuda.
Já mám ještě svůj, když tak, s sebou. Jo. Great. Hi everyone, my name is Pepa and I'm from News. I'm just another guy with Twitter and GitHub as all of you. And what we do at Muse. So we build a property management system for hotels all over the globe. And so we really have no time to be down because there is always somebody using us. So that's why we needed to develop some kind of zero downtime migrations for us. We use SQL database, so that's why the migrations takes place, and the talk will be mainly about the automated part. So let's start. So what's the typical problem? So when you do a migration to the new version with your app, there might be a downtime because the migration may cause breaking changes, like removing a column, and then the old version stops working. So there is a downtime. And it's a problem. It's not a problem when you don't have like customers at night, or you have some window over a weekend when you can do it. Like for example, I have this George app from the Czech bank, and it stops working like every Sunday. So we cannot do that. It's always this notification, I will take a rest at Sunday. I'm like, do whatever you want. And we cannot really do that. In fact, we have never done it. We hadn't had a scheduled maintenance. Now we are thinking, okay, we had only unscheduled maintenance, right?
So, and we also want to deploy really often to production as we aim for continuous delivery. We are not there yet completely, but we deploy every day. So it would be a real problem to have a downtime there. And also, it's pretty annoying to do these migrations usually because it's pretty imperative, developers don't want to do it. That results in some like old scheme in the database, like deprecated obsolete names of the columns and everything, which is not nice. It like tends to legacy schema of the database. So those are the problems. But what is the solution? What is the usual solution? Well, just don't make breaking changes, right? It's like super simple. Don't be stupid, don't be breaking changes. For example, for the column remove, you would first stop using the column at all in your code base. In the first pull request that would get deployed, and then the other pull request would remove the column completely. That would get deployed and everything is fine. There is no downtime caused by that. But what are the problems with this solution? So how do you really control the breaking changes, and what is a breaking change? Because in the end, what matters the most is the downtime. So it's not just a breaking change that causes the downtime, but with a large scale, I'm talking about tens of millions of records in a single table. You can run into performance problems in the logs and everything that will cause downtime anyway, and even worse than the breaking changes. So you have to somehow manually review it and consider it, what's the impact of the migration. Another thing is it's really imperative. As a developer, when I tell you to rename a column to another one, you won't really like it because you will need to add a new column, add the code which like mirrors the data across those two columns, migrates the data in the past, and then like after 3 pull requests, you may remove the old one with the value. That's why people usually don't rename the columns, because it's a difficult job, and it's really imperative. Basically the only thing you want to achieve is the different name with the column, but you had to do a lot of steps to get there, which is not nice. So let's see what's our idea, how we tackled it, and the solution. And the solution is not perfect. It has a very custom nature for us. We write it on demand, we learn it as we go. It's also pretty hard to write it, so it has some like specific edge cases which still might cause downtimes, but rather think of it as like it minimizes the downtime to very specific edge cases in case we have never had a downtime because of those migrations. It's really working for us now. So yeah, it's not perfect, but if I would have to like wait until it's perfect to present it to you, the idea, you would wait a lifetime because nothing is perfect. So like there is this common fallacy that all of us know that like everybody else is perfect. It's not just me, I'm not perfect. Which Dan Abramov, which is like I don't know, famous guy in front end, I think, made this article of things I don't know as of 2018. I was really surprised he does not know a lot of stuff, and he's working in Facebook. So yeah, nobody is perfect, and this solution is not. Also, so bear that in mind. I will end the philosophical intermezzo there and get right into the details of the solution. In order to present the solution, I have to like introduce our environment and infrastructure a bit, but the solution is not really technology specific. I'll just present it on our technology, but you can take the same idea and write it in whatever language or whatever technology or framework you use. But we use Entity Framework. We have a SQL Server database in Azure, and what Entity Framework allows us to do is to define the schema in the code via C# classes. It's written in .NET, and then the Entity Framework generates the schema from that. But if we would let him just generate it, he would break the stuff, so we kind of modify it. So how the Entity Framework works, he has a special table in the database where he stores a serialized schema of the database, and then he retrieves it upon initialization. He compares it to actual classes in the code, and he generates a div from that. So this is like a really good starting point for us, because you can even use entity framework just for this. It's actually not a bad idea, but we get the diff from what the developer did on the classes. And for those, is there anybody who use entity framework? Okay, not many, so I'll not dive into the details. The environment, we are on Azure. We have 2 regions, 3 app services, one West Europe Web, West Europe Jobs, and North Europe Web. In each of those app services, there are 2 slots. One is live, serving the traffic for the users, and the staging one, which is basically dead, sleeping, waiting for deployment. And in the peak, we have about 15 instances, so there is a lot of instances to migrate. I don't know if it's a lot, but it's some. And now, getting finally there more towards the deployment, this is like a rough overview of how our deployment works. It's pretty standard, I guess. The staging slot is booted up with the live configuration. Then one of the instances from the staging slot logs some platform information about a table in our database and starts migrating. Others are waiting. They know it because of the log in the database. And the single instance which is migrating the platform does mainly the schema migrations, also some other stuff. It adds new jobs and so on. And then when all instances are heated up, the traffic is swept to the new slot. That's like the high-level overview in Azure. So now I will really get into the part of what I mean by automated migrations. So Entity Framework gives us the set of operations, which is the diff of the schema and classes. So there is actually a code, a function, which takes like an array of some migration operation, as it is called in the Entity Framework, which describes the changes developers intended to make. So it may be adding a new column, renaming a column, dropping a column, altering a column, whatever. And based on that, we generate 2 sets of migrations. One we call non-breaking, the ones that are essential for both versions of the application to run. And then breaking ones, which are basically destructive, which would cause a downtime on the old version. And yeah, I have at least some picture in the presentation. This is like the rough overview. So the entity frameworks, we basically don't use it. It only provides us the information. We generate the 2 sets. The non-breaking migrations are executed directly within migrating of the new version. It allows for both apps to run, and the breaking ones are executed later only when the old version is not running yet. Actually, it's executed upon the next deploy. So the first thing to do for a deploy is to execute breaking migrations from the previous deploy, because that's when you are sure that all instances are on the good level, and you are probably not going to revert the change or something like that. So let's see really case by case how we handle specific cases. So the easiest one is dropping a column. What we do there for dropping a column, we check that the column is nullable, and if it's not, we basically crash. So if a developer on a local host removes a not nullable column, it will like blow up. It will not spin up. So he already knows about it on his local environment. And why is that? Because if he would remove a not nullable column and the new instance would insert a null value into that column, and then the old version would pick it up and try to materialize it from the null value to a not null value, it would crash. It's a pretty specific edge case. It does not happen really often. In fact, this was not checked for like a year until it happened. And yeah, and then we only generate the breaking migration, so the delayed migration actually dropping the column with its indexes. So those are pretty good starting examples. Here we can see example of the control that we are able to forbid stuff or control it somehow, and also delay or like diverge the migration into either breaking or non-breaking. Here we don't really generate something, we just put it in the right place. Adding a column checks that the type can be, for example, add it online. For large tables, again, like tens of millions of rows, if you add, for example, a row version, it will cause a downtime, basically, because it tries to generate the row version for all the rows in the database with a log, which is not good. So we just forbid it. You cannot really add a row version, and so far we didn't need it, but there is a way. I found that you basically need to add some like a binary array, generate the row version yourself, and then switch it. But there are more types that are even documented in like SQL Server documentation that he cannot really add them online with like serving the traffic to the table. So we forbid adding those columns. Those are like geography, some large arrays, unlimited strings, and stuff like that. And then also we like to have things explicit, because as you may know, Entity Framework, or I guess other ORMs, can be pretty magical. So they like create stuff on their own, and we don't want to do that. We want to have everything specifically configured in the code base. So there is a way how, by naming conventions, to check if the column was actually generated by Entity Framework or is given by us, and we forbid the ones generated by Entity Framework. So if it gives us a control over what the Entity Framework is doing. And we only say that it's a non-breaking migration, that's it. We also don't generate something here. Adding a foreign key, we check there is an index for it, because it speeds up adding the foreign key by a lot. We don't require two developers in order to keep it like later, but for the migration it has to be there. And it's a breaking change, right? So we delay adding the foreign key to the breaking part, because it could break the old version. The outer column is pretty tricky, because it basically cannot be solved. The right way to alter column is to actually create a new column and migrate the data. But we allow it with some like trade-offs that we are willing to accept. So first of all, what we do is we check that the alter column is not null, is not done on big tables. Again, like the large ones, because it causes problems. He scans the full table, and that takes a lot of time. And then the migration is really dependent on the change. So, for example, if the change is from not nullable column to nullable column, it could be both the non-breaking and the breaking. We chose the non-breaking so far, but ideally the value still has to be treated as it's basically not nullable in the new version, in order not to have the same case as with the dropping the column, that you actually insert a null value there, and which gets picked up by the old version. So for that reason, we could make it a breaking migration, which would enforce it, because the column would stay not null for quite some time after the deploy. But we chose rather not to, because this is like a really an edge case. Then making it not nullable is a breaking change, and we haven't tackled yet the like precision changes and stuff like that, just because we don't do it much. So that's but it would have to be solved the same way as with the not nullable and nullable, to see if the precision is increased or decreased, and act upon that. And then we are towards the end. This is like the grand total, the rename column. That's the most complex of all operations to do, but it allows a developer to only rename a column like as on the class, and that's it. That's all he has to worry about. So it's done via two columns, obviously. And what we do for the non-breaking part, we make the old column nullable. Then we add a new column with indexes of the old one. Then we drop the column, foreign key from the old column if there is some present. Then we create triggers, like database triggers, to synchronize the values on updates and insert across those two columns, so they are basically the same column. And then a migration to transfer all the data iteratively from the old column to the new one. When this is done, the non-breaking part is okay, and then basically the breaking ones just drop the old column with its indexes, remove the triggers, add a foreign key on the new column if it was present, and make the column new not nullable if the previous one was not nullable. So this is really just a cleanup after that. And yeah, so what we achieved with this all is that now the migrations are declarative, that developers don't need to really care about them. In fact, I haven't seen migrations that are done towards the database for quite some long time. We store them, but we don't really need to look at them because it just works. They are declarative, so developers don't need to care about them. They just like make the class look as they would want, and we tell them if it's like okay that they can do this change, or we forbid the change, or we do it for them if it's okay. The migrations are then seamless. We don't need to really care them about. They are controlled about past mistakes, so whenever it causes problem that we did not know about, for example, adding the row version or changing the column to not now was some stuff that we learned the hard way, not the nice way by reading a documentation. Then at least it has some implications, right? The naming is kept up to date because renaming a column is super simple, so everybody just do that. And it's not really that hard. Like it was hard for me when I was writing it to think of it, to like know how to inject into the framework and stuff like that. But in total, it's now about 500 lines of code. It would be much more if we would not have the entity framework to generate the diff for us between the classes and the schema. So if you don't have an ORM.js or some tool, you can try using one, or writing it yourself. It's not that hard either. So yeah, the main point of the talk was to give you the idea how we control the migrations and generate them. You can really just use it for control. If you don't feel like generating the migrations, you can just control what the developers are doing. When we have like over 60 developers now, it's really hard to pass the right knowledge to all of them. And we also really like code analyzers that forbid like bad cases and stuff like that. So these are like analyzers for the migrations for them that will tell them right away on their local machine that they cannot do it and the reason why they cannot do it. Yeah, this was I guess a pretty quick talk because that's it. Thank you for the attention. If you have any questions, I'll see Slido, I guess. I don't have internet there. Thank you.
Alright, so you can ask for questions on Slido. Hashtag Backendisti.
I'm happy that the sound is correct now because of the virus. It works.
Alright, so it seems you could shard your database per groups of customers. Why not simply run multiple independent database instances to minimize the cost of migrations?
Yeah, we could shard the database, but first of all, I would not say like simply run multiple databases. It's definitely not simple. We could do that, but we do have data which is global for all the enterprises. And yes, there would be like a separate service and everything. To give more like perspective into this, the system started as like a really small project with entity framework. It's still a monolithic application. We don't have microservices and all this cool stuff, but we always say we are in this boring technology club that we try to use the stuff like unless it works. So far it works for us, yes. We have to take care about like the big migrations, but we have solved it. It's not a big problem for us now. We have to take care more about the performance on really large tables. But on the other hand, we don't have to solve many other stuff with multiple databases, right? So with the multiple databases, when you have really data, like you want, for example, a chain data, that there is a chain with, let's say, 100 or even more enterprises all over the globe, and he wants a reporting on the chain level and stuff like that. So like sharding the database is really not something that you want to do, it's something you will evolve to, right? So We are getting there because our main database right now has about like a terabyte of data, which is pretty a lot. We are now starting to use Cosmos DB for some stuff which does not belong to SQL Server. Then we also use blob storage for files and stuff like that. So we are like postponing the sharding, but yeah, like probably in a year or two, we will have more services and more databases and stuff like that. But we are trying to avoid it because it adds a lot of complexity to the system. And it's like, apart from some performance stuff, it's pretty okay to have it in a single database. And not all tables are that big. Like the biggest table has about 100 millions of rows, but the usual ones have 10 millions at most, which is okay.
Do you have multiple applications connecting to the database? If yes, how do you synchronize changes?
No, we have just a single application connecting to the database. We have this like backend, which is like the core of the system, which is exposed to the API to all our products. So we have the data team, which is connecting to the database, but they are just reading, not really writing. So no, we don't have that.
If a migration is running for several hours, that means that the deployment is blocked?
No migration ever took several hours. The migrations usually finish in few minutes. So yeah, it means you cannot really deploy another version during the one before it's initialized. But there is a mechanism where you can like stop them, and if it fails, it unblocks it. But it hasn't occurred to me that it was more than 5 minutes or so. So no, it's not a problem since it's not ours or something like that.
Next question. Don't proper code reviews discover most of the problems?
We have a lot of code reviews. We actually have 2 levels of code review where a junior guy first picks up the pull request and then a senior guy picks up the pull request and merge it. So yeah, we have the code review, but it's best. We have an article on our blog which is called Automating the Code Review. And why would you comment the same stuff still over and over in the pull request? Like a simple example, using datetime.now, you really don't care about the time of the server, right? So we have an analyzer which forbids the usage of datetime.now, and the project won't compile if somebody uses that. Or ordering a string without a localization, because ordering a string without the localization is basically random. So we also forbid that, and we have a lot of these. And like we believe that if you automate it, that you basically tell it to the developer automatically by a compiler or some error during the initialization, you don't have to repeat the same stuff over and over in the pull requests. Or I hope it answers the question.
Yarda is asking, how do those migrations look like in code?
Yeah, so pretty simple. Like the entity framework has a way to support multiple databases. That he has this SQL generator where he has this that he generates the SQL migration based on the operations, and we use that SQL generator to generate our migrations where we have the set of operations, and then we basically say if the operation is drop column, do this. If the operation is remove column, do this. All the operations return the 2 sets of migrations. Then we concatenate all the sets and execute them. Of course, this is really simplified, but it's not actually that hard or cryptic.
Okay, thank you, Pepa, for your great presentations.
Thank you.
And for the answers. All right, so I would like to thanks also to JetBrains for helping us organize this event and providing this cool place and refreshment. And thank you to all of you that you came here. And please don't come home yet, because we'll have a networking session, so you can connect with either the speakers or with each other in here. And we still have, I guess, some of the beer in the fridge, so feel free to take it. And thanks again for coming.